Out of curiosity, how many people are here interested in the concrete printing? Okay. Are we ready? We got it up? One thing that I really want to give credit to first, we wouldn't be here without Professor Davidovitz. And I'm really honored to have Alex and Ralph supporting my company to do new products in the United States. I think it's important that we get started in the United States because of the requirements for regulation on building materials. We have the opening there that has standards for different materials instead of just Portland. We can actually use a geopolymer as long as we meet those criteria. So that's why I think it's important for us to get set up there and set example for the rest of the world to be able to realize that this is entirely possible. So one more thing, a couple of years ago I did a project and I did these book covers for the books. Ralph is going to bring some tomorrow, and you have all the conversion charts on the inside, and I indexed it so you can break the book down in chunks to swallow it. I know it's quite a bit, but it makes it easier for me. So, okay, printing a geopolymer house is a lot harder than it sounds. It's going to look a lot easier than it was, and I have to give main credit to Andrey Dudnikov. It's his mix, and he was a champ. He watched that pump and was ready for it every minute that we were printing. And so the major portion of what we were able to do is really on his behalf. Of course, we needed a printer to put it through, and then my company that kind of tied it all together. So I have a video from Jared Gross, and I'm going to go ahead and run that because I think it's probably the easiest way to see this. I played that because it gives you most of the information that most people want to know anyway. We do have sample kits in the US that we put together for people to get their hands on. Publicly, I do want to mention that Warner did say that I would be able to be getting some silicates in the US, and I'm trying to get those so that I can start getting them into the universities so they can get some good materials to start learning to handle geopolymer and create that next generation of entrepreneurs to do our material. So, okay, so some building. Okay. So as I mentioned, we went ahead and printed the foundation. I even did a little bit of some elevations for the rebar to hold that up into the concrete. Made a lot cheaper and easier, not wasting wood.
This one?
Yeah. And then that's with the deck and the printer, the strong 3D printer that Emmanuel will go over next. That's kind of just us in operation, getting our first few layers down and what it looked like during the night. We tried it during the day, and that was not very good, so we went ahead and switched to night. Yeah, another photo of our operation. That's pretty much out in the desert and the whole circumference. Here's the plumbing that we put in. I just cut through the wall and added it in. This white material here is actually a cure that we spray on it to maintain the moisture inside. And as you see, we're building up. That's the material. I have to mention, once you use geopolymer and 3D printing, you'll never go anywhere else. It's a lot of fun material to be able to work with, and it's a quality that you can't get in anything else. So I put this one in to show how one side is higher than the other. This is where the Intl deck will come in. Just kind of showing you the structure with the columns in here with the rebar sticking up. We did do 2 elevations where we did a dowel in the ground, printed up 3 feet, screwed in another rebar with a coupler, and then just kept going up. And here's our operation. I wanted to show we used the Eimer pan mixer. and we also used a Maya pump. And we kind of reconfigured our formulations because we realized that, yeah, geopolymer takes a lot of mixing. However, we worked to be able to get it on equipment that you can actually get off the shelf instead of having to build something to be able to use it. I put this in because you can see the gap in the windows. Actually, what we're going to be doing is cutting the edge of the doorways and windows and then mounting the framework in there to put the doors and the windows in. You can hit that video. I guess it can't go either.
It's a video?
Yep. So this is us printing at night. Lays out. You'll see some of the rebar. We use basalt rebar between the walls to be able to add structure to it. And then inside you can put your electrical, your insulation, and so forth. A lot of people like to cross print and everything else.
Is it the actual speed?
Yes.
Oh, yeah.
That's but.
How many meters per second?
It's less than a meter per second.
So, and then next
So
one.
yeah, I can explain why. Because our machine was made for concrete, and to push geopolymer, you need a bigger motor, stronger motor on the auger side. So we were limited by that. So this is what happened.
We tried both, feeding from hose, and then wound up with an auger extruder because it just gives you a lot more control. The next. There it is. There's the finish. Getting it all done. And then I added one more video because most people don't know what Intl deck is. And basically it's these styrofoam panels, and they have the beams in them, and the concrete goes down into the wall. So you can actually pour this, a monolithic pour that seals it, and it can either be a roof or your next floor to build on. But then you have the beams going across to support an insulated concrete roof. So that's it.
Yeah, so I'm gonna talk about the machine if you're interested about it. It's a very simple machine that was meant to be disassembled by 2 people, to be carried by 2 people, and to be moved everywhere else you need to print. The machine is taking like 6 amps an hour, so it's very low consumption. It's servo motor plus computer to control everything. From that, there's not much more to say about the machine. If you have questions, please ask questions about the machine.
So, any other questions for us here?
What's the dimension of the machine?
The house was actually 16 by 30 feet.
Yeah,
you do meters, so
I think it was 3
10
meters.
meters by 3.
Yeah, 10 by 3 by 260 high. Yeah.
You have some tests with the compressed air to make the foam?
This mix does have a little aerating agent in it to help lighten it up. It also has glass. Actually, I did bring some samples for those that want to look at the composite of the material for you to be able to get a hold of.
And what was the filler?
An extruder. The pump was a Maya pump.
The filler. The filler, what is this?
Oh, the filler, expanded glass. Yeah, actually, we estimated our comparison to Sika printing material, and with our estimates, we're 7 cents a pound cheaper than their bagged material, because it all has the sand and everything in it, and you're shipping a lot of material where we're also just sending binder, and you buy your own sand. The insanity of actually printing with a Portland mortar that's going to actually fall apart in 20 to 30 years, I, as a licensed general contractor, realized that the liability that you're creating on a home that will start to deteriorate, they're going to come back after those contractors and have a big problem. And just have a house that will last at least 1,000 years is only common sense. We can't keep rebuilding our infrastructure every time something falls apart. And they use Portland because it's cheap.
Yeah, and there is something very important also for 3D printing. Since you can have cold drawing with using concrete, it's very important. Geopolymer is way more forgiving for that. So it's easier to use geopolymer that way. And it was also a big adventure what we had together. And so I want to be thankful for everyone that was part of the adventure. Because it seems like simple when you see it on the picture like that. But when you are in the heat of 45 degrees Celsius, or you have to work like 14 hours or something like that, and you still have to work at night to make it happen, that's another story. But everyone stayed together. We have some hard moment, I would say, but we went through. And now we know how to print a house with geopolymer.
Okay.
So thank you.
We'll continue after the break. General.
Hello, everyone. We are very happy to see you, and we are very grateful for the opportunity to be present here, virtually this time. Those people who are not new to the Geopolymer Camp know that we haven't missed a single Geopolymer Camp since 2015 when we first came and got acquainted with this technology. But we will catch up on this next year for sure, and we will see you all personally again. Meanwhile, let us share, as usual, our progress, which we have achieved within the last year. And as you all know, in 2022, we started our 3D printing factory, and we started printing inside the warehouse in the controlled and more or less controlled environment. And here you can see the process of the first objects that we have 3D printed, some precast panels for the house. And we had a chance to experiment with the material, with the design of these objects, and we have tested over 250 recipes to achieve different properties. So we were able to play with aggregates, fillers, binders, to adjust the setting time, to adjust the properties of the mix, flow, strengths, and so on. And we could print large objects which required slower setting time, as well as we were able to print very fast high objects, go up very fast, so the setting time was really short, and it was enough for the mix to harden and hold the whole structure. So this is our achievement, the 2.5 meters high panel, which we have 3D printed non-stop in one set. It took us about 4 hours, a little more than 4 hours to 3D print it. And we also covered it. If you see this white cover on top, it is a curing that would help protect it from too fast water evaporation, which was still an issue because though it's in the warehouse, you still have your temperature, you still have your low humidity, which will affect the properties of your final product. But this year we have moved even further and achieved a new, very important milestone in the development of 3D printing with geopolymers. And we have 3D printed the first in the world house made with geopolymers. And we have done it outside. That's why our presentation is called Fight Against the Nature, because once you go outside of the warehouse, it's a totally different story. And I will give the word to Andrey, who will explain a little more.
Yeah, I'd like to share with you the experience that we had during that print in the house. And at the beginning, we were so naive, printing in a warehouse in a controlled environment, that we can do the same outside in the desert. And we started our trials. In the desert in Nevada, and we did very good. At the beginning, the first layer, as you can see, was perfectly laid down and was smooth. Everything was great. But we haven't considered the fact that the temperature is not stable, is not low. It's about 40 degrees Celsius, as well as the humidity is almost nothing. And the water was evaporating from the material very fast. And the strong winds also made its job to ruin the material. So at first it was pretty good, pretty nice. But when we faced this nature, we realized that we have to do something else. We have to change something, not only the material properties that we had to change on time, on site, having the material that we had, but also the approach for 3D printing in the wild, in the nature. So covering material helped a little bit after we discovered that cracks and there was a severe cracks that we didn't understand why they happened, but as I explained you before, that it was because of the absence of humidity, high heat. It was really stressful for the material to be able, without any additional treatment, to withstand that temperature. The equipment also was not capable to work at these temperatures. The pumps were heated, the hoses were heated, and the only reasonable solution for that was to go and print at night. So we started printing during the night time when the temperature is lower and stable, and we have no direct sunlight, we have less wind and higher humidity. And that night shift printing worked really great, and you can see we went up very fast and achieved our goal to 3D print the house and learn our lessons that you have to consider the environment that you are printing, and you have to adjust to the nature, not to try to fight against it. And here the final result that you can see of the house that has been done in the desert. And I will tell Marina to continue.
Yeah, what we have realized during this printing and the previous printing in the warehouse as well is people is your greatest asset. All that it takes, the maximum that it takes to achieve a good result, to achieve your goal is a team. You need to build a strong and very reliable team of people who are willing to invent something, who are willing to experiment. And we are very grateful to John and Emmanuel, who came with their 3D printing all the way from Canada. And it's from 3D print, yeah. John brought his 3D printer, he adjusted it on site, he made some engineering solutions, inventions, and so on. Emmanuel did a very great job. He was so devoted. He was not afraid to fail and start again and start over and over again. Without these guys, it wouldn't be possible, as well as without William from Geopolymer International, who brought us all together and made it possible for this project to be realized on his site in Amagosa Valley. And Doug, who learned so fast how to work with geopolymers, and he was absolutely helpful on job site because he could feel the material, he knew what has to be done and react very fast. Because if anyone has ever 3D printed with whatever material, they know exactly that when something goes wrong, you need to react very fast. You have sometimes several minutes to clean your system. Otherwise, you will get stuck for hours with cleaning the hoses, cleaning the pumps, and you probably will have to throw away all your hoses and sometimes even the pumps, which costs you a lot of time, money, effort, tears and sweat, and so on. So to avoid that, you need to have a team where people know exactly what everyone has to do, who are not running around crazy, throwing their tools, not knowing what to do, panicking. So this is a key to success. And of course, we would do nothing without our engineering support from Ralph and Alex, who consulted us from distance and helped us adjust the recipes, gave us very valuable advices, what to try to cope with the conditions that we had, with all this severe heat and dryness and wind and so on and so forth. So what makes geopolymers so perfect for 3D printing? Of course, we all know about the outstanding properties of being acid resistant, fireproof, very structural. It's not new, and also being sustainable. But what makes it even better for 3D printing is the chemical bonding that we have in the material. So we were able to print several layers one day, stop, come the next day, start again without any additional preparation of the surface, and the layers would bond together chemically like it's a monolith. So this is not possible with any cementitious materials, where you have to glue them together. Here it happens naturally. Geopolymers has a very good adhesion to any basic materials except plastics. But what you have to do is be careful with your curing not to apply it on the surface where you will be 3D printing the next day. In that case, you can create a film which will prevent the adhesion, of course. And also, geopolymers are very easy to make fast setting and very high strength, even much easier than in any cementitious materials, because it's their nature of fast setting and high strength. And also what we have now, we have a worldwide presence with our materials, and we are continuing to spread the knowledge and technology and geopolymer materials internationally. And we have our products available, but we also adjust them locally to the local raw materials in each part of the world. And this is what we do. We go to the country of the presence, we study their raw materials, which they have. In each country, it will be a different type of raw materials. And of course, this will influence a lot the final properties that you can get and the final products that you can get out of those raw materials. And it makes no sense to try to copy the results that you had in one place, in one part of the world, and just paste them into another part of the world. This doesn't work. You have to do your R&D, you have to do your homework, study the raw materials, start from there, then adjust your recipes, adjust your products according to the results that you have. And these services is what we are doing in RENCA, is what we are offering in RENCA. We can do all of that studies, starting from scratch and ending with a final product, with a final result, and testing the final products in the local laboratories according to the local certification methods.
Yeah, and also we have ready-to-sell products, for example, geopolymer binders, precursors, and geopolymer reagents, as well as final customized products like repair motors. We had experience before using the geopolymer repair motors at -20°C. Now we have that experience at using that almost at 50°C. So it's a whole range of temperatures so that our material can work perfectly, as well as 3D printing motors that has to be adjusted to each type of printer. It's a slight adjustment, but we know that path and we know how to do that now. And we also have a network of our partners and clients with whom we've been working for many years, and get a lot of knowledge from them and teach them how to work with geopolymers. And we welcome you to be our next partner and learn from geopolymer technology. So this is our contacts, and you can write us email, and we'd love to reply to you and get to your final project. Thank you.
Thank you very much.